We explored pointers, and I mentioned that they would be most useful once we also dive into more complex data types. Well, in this course section, we are going to dive into such data types where we then also see reasons or situations where pointers can be helpful. We are going to dive into the struct data type, and we're going to learn how this struct thing helps us structure our data and when we might want to use it. And for that, in this course section, we're going to learn what exactly a struct is and why we might want to use it. And of course, we're going to see it in action with some dummy code before we then, in the next course section, also use the struct concept or the struct structure in a more realistic project again. Now, for this course section, I prepared a little starting project, which you find attached. It's one file mainly, and then this module file. And in this structs Go file here, you find a bunch of code which generally only does things we already saw before. I got a main function, I got a reader, and in the main function I'm calling the getUserData function, which is this function here, where I gather some user input from the command line so that I can then enter a first name, a last name, and a birth date. Then here I create a time snapshot. I get the current timestamp by using the now function provided by the built-in time package. Then we might be doing more awesome things. It's of course just a simple dummy example, so we're not doing anything here, but it would be realistic that we are building an app where we are fetching some user data and where we then do more amazing things with that data. Here I'm just printing it to the command prompt so that we see that all of that works correctly. And therefore, if you download this and create your own Go module with the go mod init command, giving it a unique identifier, you can then run this module, and in the command prompt, you are then prompted to enter your first name, your last name, and then also your birth date. And here I'm coming up with some date. This is not my actual birth date. And if I hit enter, then this is all being output down there, as you see, and therefore this application overall works. Now here we're not doing anything new besides this timestamp. The rest of that code is all code we saw before. But there is something special about this example and this simple use case, something which you will encounter in a lot of applications you'll be building. We have some data, first name, last name, birth date, and the created timestamp that actually kind of belongs together. Nonetheless, here I'm managing that data in 4 separate variables. And that's of course not wrong, but if you think about more complex applications where you might be dealing with users and maybe products and maybe orders if you're building an online shop, then you often have packages of data, you could say, where multiple pieces of data are grouped together. For example, this data here could describe a user of our application. And very often you might want to pass that data around in a package, so that if we had some other function that is responsible for outputting user data or for storing data in a database, we can pass the entire user data package to that function instead of having to pass individual variables. So the data types we learned about thus far are not enough. Strings and integers and floats and so on are all great for simple pieces of data, but if we then want to combine that data and describe a more complex entity like a user, then these data types do not suffice. And that's why Go has a special data type that we can use to group data together, the struct data type. And we have similar concepts in other programming languages. In JavaScript and Python and many other languages, we have so-called objects. And the struct is basically Go's equivalent to those objects, in case you did work with other languages before. Now, in Go, in our Go file, outside of the function, just in the file like this, we can define our own data type, our own struct, by using the built-in type keyword. This tells Go that we want to define our own data type because the built-in types are not enough. Then we can give this type any name of our choice, for example, user. But that name is up to you. And again, you can start with an uppercase character if that type should then also be available outside of this package, in case you split your project in multiple packages or you distribute it as a third-party module. And you can start with a lowercase character if that should be a type that's only usable inside of this package. So just as you learned it about variables and functions, the same thing applies to this custom type. Now here I'll go for an uppercase character, because here it doesn't really matter to me whether that's available outside of this package or not. And then we need to add the struct keyword. With that, we are telling Go that we want to define our own type, and that this type should be a struct thing, a structure, so to say, an object in other programming languages. Then we add curly braces, opening and closing, and between those curly braces, we can now describe our own data type. Because keep in mind, the idea behind the struct is that we group together related data. Now, between those curly braces, we can simply define the different data fields that we want to have in this struct. And here you can come up with any names for these fields you want. Like, for example, a first name. A user should have a first name, we could say. So here we then just add first name, just as if we would be defining a variable, but without the var keyword. And then you need to define the type of data that should be stored in that field. And here that could be a string. And that's how you now define a user that will have a first name field, which is of type string. And if we later want to create such a user struct in our code, so if we want to use this blueprint, so to say, to create a concrete instance of that blueprint, we will be able to assign data to that field. And of course, you can also add more than one field. You can also add a last name, which is of type string, and then maybe a birth date, which is of type string. And the names I'm choosing here happen to be the same names as I have them down there for the variables, but you don't need to use the same names. You can use totally different names here. You don't need to pick up those variable names. But now I got that. I'll also add a created date here. And here the type will actually be a special type. The type will be time.time. And that's a strange type which we haven't seen before, but this is actually just a custom type defined by Go. If you hover over it, you see it's a struct, but not a struct defined by us, but instead, this is coming from the time package, which is built into Go, so it's a struct defined by the Go developers. So besides integers, strings, floats, and so on, so beside these basic types, we can also define our own more complex types, and there also are a bunch of predefined more complex types that are part of some of the Go packages, like this time struct type that was defined by the Go developers. And now with that, we're saying that we will have our own data structure called user, which will have these data fields. And we can now also use this as a custom type. And therefore, in the main function here, we could now say that all that gathered data should be grouped together into such a user object, into such a user structure. For this, we could, for example, already define a variable here, default user or new user, for example. Name is up to you. And make it clear that the type of data that should be stored in this variable should be user. And of course here I'm picking up my own type, because again, We can define our own types with that struct concept, and we can then of course also say that a certain variable should only be allowed to hold such kind of data pieces then. So here in new user, we can't store a string, we can't store an integer, instead we'll need to store such a struct. But how do we now use this struct blueprint here to then create a concrete instance of it here in our code once we got all that data?